Have you ever noticed how a single moment of pressure can change the way your mind feels, your focus narrows, and your world seems to shrink, as if the brain quietly shifts into a different version of itself designed not for peace, but for protection? Because stress is not just something you feel emotionally, it is a biological event unfolding in real time inside the most complex organ you possess. The first idea to understand is that the brain treats stress as a signal of importance, a cue that something in the environment demands priority, and in response it begins reallocating its resources, moving energy away from reflection and toward rapid reaction, because in survival terms, speed often matters more than nuance. The second idea is that a small region deep within the brain acts like an alarm system, scanning constantly for signs of challenge, and when it senses a potential threat, whether physical or psychological, it sends powerful messages that ripple through neural pathways, shifting the brain's balance from calm evaluation toward readiness, even before you consciously understand what is happening. The third idea is that stress changes how different brain regions communicate with each other, strengthening circuits involved in vigilance and weakening those involved in long-term planning, empathy, and complex reasoning, which explains why under pressure we often feel less patient, less creative, and more focused on immediate concerns. The fourth idea is that the brain under repeated stress begins to adapt, not by becoming stronger in a simple sense, but by becoming more efficient at detecting and responding to strain, which can gradually reset what feels normal, so a state of alertness that was once temporary becomes a background condition influencing mood, sleep, and attention. The fifth idea is that the brain remains capable of change in both directions, and just as it can learn patterns of stress, it can also learn patterns of safety, using experiences of rest, stability, and supportive connection to rebuild balance in its networks, reminding us that the biology of stress is not a fixed fate, but an ongoing conversation between the brain and the world it is trying to understand. Stress begins in the brain as a signal of importance, not as a weakness or failure, but as a built-in mechanism designed to help a person respond to situations that demand attention. When the brain detects pressure, uncertainty, or challenge, it does not pause to debate whether the situation is truly dangerous in a modern sense. Instead, it evaluates urgency. Anything that appears to threaten safety, stability, or control is marked as a priority, and this marking sets a series of biological adjustments into motion. In that moment, the brain quietly reorganizes how it uses its energy, because the body's resources are limited and must be directed where they seem most needed. Under calm conditions, the brain invests more effort in reflective processes. It supports careful thinking, long-term planning, emotional balance, and social awareness. These functions rely on networks that take time and energy to operate. Stress shifts this balance. The brain begins diverting resources away from slow, detailed analysis and toward faster systems that support immediate action. This is not a conscious choice. It is an automatic redistribution shaped by evolution, where survival once depended on reacting quickly rather than thinking deeply. As this shift occurs, attention narrows. The brain filters information differently, focusing more on what appears relevant to the perceived challenge and less on background details. This narrowing can feel like heightened clarity in some moments, but it can also reduce perspective. Subtle information, creative ideas, and emotional nuance may receive less processing. The brain is not trying to limit potential. It is attempting to increase efficiency under pressure. From a biological standpoint, broad curiosity is less urgent than quick decision-making when a threat is suspected. This change in resource allocation also affects how the brain communicates with the rest of the body. Signals that support alertness become more prominent. Heart rate may increase, breathing patterns may shift, and muscles may prepare for action. These physical responses are not separate from the mental experience. They are part of the same coordinated effort to prepare the organism for immediate demands. The brain is acting as a central coordinator, adjusting multiple systems at once to align with its new priority setting. Importantly, this process does not distinguish sharply between physical danger and psychological strain. Social conflict, workload pressure, uncertainty about the future, or internal worries can activate similar neural priorities. The brain interprets these experiences as forms of challenge that require readiness. Over time, if such signals are frequent, the repeated redistribution of energy can influence how easily the brain enters this state. What was once a temporary adjustment may begin to feel familiar, even habitual. Understanding stress in this way changes how it is viewed. It becomes less about emotional fragility and more about biological strategy. The brain is attempting to protect, to prepare, and to respond using patterns that once ensured survival, reallocating its precious resources towards speed, focus, and immediate action whenever it judges that the moment demands readiness over reflection. Deep within the brain, there is a network that functions like an internal monitoring system, constantly scanning the environment and the body for signs of potential challenge. This system operates largely outside conscious awareness, comparing incoming sensory information with past experiences, memories, and learned associations. Its purpose is not to create fear, but to detect significance. When it senses something that resembles danger, uncertainty, or loss of control, it responds quickly, often before the thinking part of the brain has had time to fully interpret the situation. This speed is part of its design, shaped by the need to protect the organism in unpredictable conditions. When a possible threat is detected, this alarm network sends signals to other regions of the brain that coordinate the stress response. These signals act like priority messages, indicating that attention and resources should be redirected. The thinking regions responsible for careful reasoning and long-term perspective may receive less influence in that moment, while areas involved in rapid reaction and emotional intensity become more active. This shift can happen in fractions of a second, creating a felt sense of tension or urgency even when the external situation appears manageable on the surface. What makes this system remarkable is that it does not rely only on current events. It also draws on memory. Experiences from the past, especially those associated with strong emotion, shape how this alarm system interprets the present. A tone of voice, a facial expression, a deadline, or a particular setting may resemble earlier moments of difficulty, leading the brain to react as if a similar challenge is unfolding again. This is not a flaw. It is a learning process intended to improve prediction. The brain uses history to anticipate what might happen next, sometimes activating protective responses based on patterns rather than direct evidence. Because this monitoring system works so quickly, its signals often reach the body before conscious thought forms a clear explanation. A person might notice a racing heart, shallow breathing, or muscle tightness and only later realize what triggered the reaction. In this way, the body can feel stress before the mind puts it into words. The alarm system is prioritizing survival by preparing the organism first and analyzing the situation more fully afterward. This process also explains why imagined or anticipated events can produce real physical responses. The brain's alarm network responds to perceived threat, not only to actual physical danger. Worry about future outcomes, social concerns, or internal doubts can activate similar neural pathways as external challenges. The brain is reacting to meaning, to signals that suggest uncertainty or risk, regardless of whether the source is outside or inside. Understanding this mechanism reveals that stress begins as an interpretation process. The brain is not simply reacting to the world as it is, but to the world as it predicts it might be, using rapid signals to mobilize the body whenever it senses that preparation may be needed. Stress changes the way different parts of the brain communicate with each other, quietly shifting the balance of influence between networks that serve different purposes. Under calm conditions, brain regions involved in reflection, emotional regulation, and long-term thinking maintain steady dialogue with areas responsible for memory and social understanding. This communication allows a person to weigh options, consider consequences, and respond with flexibility. When stress enters the picture, this pattern of communication begins to reorganize. Circuits linked to vigilance and rapid detection of potential problems become more dominant, while those that support patience, creativity, and emotional nuance may have less influence. This shift is not random. It follows a biological logic centered on efficiency. In situations that feel urgent, the brain prioritizes speed over depth. Networks that scan for change, track possible threats, and prepare for quick action increase their activity and connectivity. At the same time, regions that require more time and energy to process complex social and emotional information may reduce their activity. This can make thinking feel more narrow and focused, but also less flexible. A person might find it harder to see alternative perspectives or to regulate emotional reactions because the systems that support those skills are temporarily less engaged. Memory processing is also affected by this change in communication. Under stress, the brain becomes more attuned to details that seem relevant to survival or performance. Strong emotional elements of an experience may be encoded more intensely, while neutral or contextual information may receive less attention. This can shape how events are remembered later, sometimes emphasizing the emotional tone more than the broader picture. The brain is attempting to learn quickly from what it interprets as significant, adjusting its memory priorities accordingly. Another effect of altered communication is seen in social behavior. Regions involved in empathy and social reasoning rely on balanced interaction with emotional and reflective networks. When stress strengthens vigilance circuits, social interpretation can become more rigid or reactive. Small misunderstandings may feel larger, and patience may decrease. This does not mean empathy disappears, but its expression can be influenced by the brain's focus on managing perceived pressure. Over time, if stress becomes frequent, these communication patterns can become more habitual. The brain's networks are shaped by repeated use, and circuits that are activated often tend to strengthen their connections. Vigilance pathways may become more efficient, while those supporting calm reflection may require more deliberate effort to engage. This is an example of the brain's adaptability, sometimes called plasticity, which allows it to adjust to repeated experiences. Recognizing this process helps explain why people may feel mentally different under pressure. It is not simply a change in mood, but a reorganization of neural communication designed to prioritize readiness, directing attention and processing power toward immediate concerns while temporarily reducing the influence of systems that support broader, slower, and more emotionally balanced thinking. When stress is experienced repeatedly, the brain does not treat each episode as an isolated event. Instead, it begins to adapt to the pattern, adjusting its baseline expectations about the environment. Systems that were designed to activate temporarily during moments of challenge may start to remain active for longer periods. The brain, shaped by experience, learns what seems typical. If frequent demands, pressures, or uncertainties are present, a state of heightened alertness can gradually feel familiar, even when no immediate threat exists. This is not a conscious decision, but a form of biological learning that reflects the brain's effort to stay prepared. As this heightened state becomes more common, the threshold for activating stress responses can shift. Signals that once might have been interpreted as minor may now trigger stronger reactions. The monitoring systems in the brain become more sensitive, scanning more intensely for signs of difficulty. This increased sensitivity can be useful in genuinely risky environments, but in modern daily life it can lead to persistent tension. The brain is trying to anticipate and prevent problems, but the cost is a reduced ability to fully settle into calm states. This ongoing alertness influences multiple aspects of mental experience. Attention may become more focused on potential issues, making it harder to relax or disengage from concerns. Sleep can be affected because the brain maintains a level of vigilance that interferes with deep rest. Emotional responses may feel more immediate or intense, as circuits associated with rapid reaction are more readily engaged. These changes are interconnected, forming a pattern that reflects the brain's adaptation to repeated stress exposure. Importantly, this process demonstrates the brain's plasticity, its ability to change structure and function based on experience. Connections between neurons strengthen when used often, and networks that support alertness and rapid detection can become more efficient with repetition. At the same time, pathways associated with calm reflection and emotional balance may be used less frequently, requiring more effort to activate. The brain is not becoming damaged in a simple sense, it is reorganizing according to the signals it receives most often. This adaptation can also influence how a person interprets internal sensations. Physical cues such as a faster heartbeat or muscle tension may be noticed more quickly and interpreted as signs that something is wrong, reinforcing the cycle of alertness. The brain and body are engaged in a continuous exchange, each influencing the other. When the brain expects challenge, it prepares the body, and the body's state can in turn reinforce the brain's expectations. Understanding this shift in baseline helps explain why returning to calm can take time. The brain must learn new patterns that signal safety and stability. Just as repeated stress shaped its expectations, repeated experiences of rest and predictability can gradually recalibrate its sense of what is normal, allowing alertness to become a flexible response once again rather than a constant background state influenced by the history of how often the brain has been asked to remain on guard. The brain's ability to change does not move in only one direction, and this is one of the most hopeful aspects of its biology. Just as repeated stress can strengthen pathways linked to vigilance and rapid reaction, repeated experiences of safety can strengthen networks associated with calm, balance, and emotional regulation. The brain is constantly learning from patterns, adjusting its internal wiring according to the signals it receives most often. When those signals begin to include steadiness, predictability, and supportive connection, the nervous system gradually updates its expectations about the world. Safety, in biological terms, is communicated through consistent cues. Slow, steady breathing, regular sleep rhythms, gentle physical movement, and environments that feel familiar all send information to the brain that immediate threat is unlikely. These signals influence regions that regulate stress responses, encouraging a shift away from constant readiness. Over time, circuits that support relaxation and reflection can regain influence, allowing the brain to distribute its resources more evenly instead of focusing primarily on defense. Human connection also plays a powerful role in this relearning process. Supportive interactions, calm voices, and a sense of being understood provide cues that the environment is stable. The brain evolved in social groups, and signals from others help regulate internal states. When a person experiences consistent, safe relationships, networks involved in emotional regulation and trust become more active. This does not remove life's challenges, but it changes how the brain interprets them, reducing the likelihood that every difficulty will trigger a full stress response. Repetition is central to this process. A single moment of calm may feel pleasant but does not necessarily alter deeply learned patterns. When calm experiences occur regularly, they begin to shape neural connections. Pathways associated with safety are activated again and again, and with each activation, their efficiency increases. The brain becomes more practiced at returning to balance after activation. This flexibility is a key feature of resilience, the capacity to respond to stress without remaining stuck in it. Physical sensations also contribute to this recalibration. When muscles release tension, breathing deepens, and heart rhythms become more variable, the brain receives feedback that the body is not in immediate danger. These signals influence central networks, supporting a downward shift in alertness. The relationship between brain and body is continuous, with each shaping the other through ongoing communication. This capacity for recovery highlights that stress patterns are not permanent states but dynamic processes. The brain remains responsive to new information throughout life. With consistent signals of safety, rest, and supportive environment, neural networks can reorganize once again, strengthening pathways that allow for clarity, emotional balance, and a wider sense of perspective, reflecting the brain's enduring ability to adapt not only to challenge, but also to stability and care.